listed there. So this will be a nice one because now we can practice kind of how angles are named. Practice using supplementary angles, looking at right angles, all that good stuff. So 13, we're using the diagram. We know that one of the angles in the diagram, ACB, is 65, and then we're going to find each of the following. So ACB, I'm going to try to locate where that angle is, and then we'll fill in that that's 65. So ACB, when they're naming the angle, they're going to start at a point, and then you just follow the 3 letters that are listed, and that's going to create your angle. It's kind of like you're following a road map. So they're saying start at A, then go down to C, then go over to B, and then that's going to represent the angle they're talking about. So this angle right here is 65 degrees. So that's all we know so far. Now we're going to start to see if we can figure out any of the other missing angles. So number 13, we want to figure out what is the measure of ACD. So if I follow the path of ACD, I start at A, I go down to C, and then I go over to D. That's the angle that we're talking about. So we're actually looking at those 2 angles that are kind of combined there. I know that angle ACB is 65, but I don't know what BCD is. I do know that it's got a little arc in there, and I kind of covered it up with my blue. I know it's got a little arc in there, but I don't know exactly what that measures. I just know it's congruent to that FEC over there. Does anyone have any ideas on how I could find the measure of this blue angle right here? ACB. Any thoughts on that one? Remind me your name again.
Carson.
Carson Hess, right?
Yeah, it's the same as ACF. So you can tell it is 90 degrees.
Perfect. So it looks the same as ACF. ACF is 90 degrees. And then yes, ACD is also going to be 90 degrees. Perfect. Another thing that we can use on this one, and we're going to use a ton in geometry, and it's one of those postulates or just those given facts, is anytime you have a straight line, how many degrees does a straight line always make? 180 every time. So I know that that's 180. What Carson said is that ACF, we know that that's 90, so 90 of those degrees are taken up. How many degrees are left? 90 degrees. So ACD is going to be 90 degrees. So we'll take that. Perfect. Now we know that ACD is going to be 90 degrees. And as we continue looking here, we'll keep that in mind. Now we look for BCD. So now we're looking from B to C to D. And BCD, if I look carefully, it's going to combine with ACB, which I already know is 65. And we just looked at this angle together, so ACB, BCD, together they're making that angle ACB. And what did we just say? How many degrees is that ACB? 90. So any ideas? How could I figure out then that blue angle BCD? Any thoughts?
90 65.
Excellent. We know it's got to be 90. We know 65 of those degrees are taken up. So we subtract it. I'm getting 25. Is that what you guys are getting?
Yeah.
Perfect. So there's 25 degrees. Now we go to ECD. Let me erase that so we don't get... when you're looking at these diagrams, you kind of have to compartmentalize. You have to kind of forget. So in these last couple problems, all this stuff over here doesn't really matter. We're just focusing on the angles that we're looking at. ECD. All right, we got to find ECD. I think I see it there. So ECD, we've got, goes from here to here. So there's the angle we're focused on, ECD. Well, I do know one thing, it's a 2, so it's going to be greater than 90. So any thoughts on how I can start figuring out ECD on this one?
Okay,
Gabby.
so like the other side, like FCA and ACB are like, what is it called? You know what I'm saying?
Yeah, I
So
do
you
know what
could
you're
add
saying.
those 2 together, like 65 and 90.
Let me catch up to you here. So I'm going to highlight these in red. So this and this, correct?
Yeah.
So adding those two together, 90 and 65, gives me a total of 155. Okay. And they do that thing, right, with the other side. So what we have here is in geometry, a big thing that we're looking for, and I'm going to try to highlight this in green. What you have here is this X formation, which you have two segments intersecting, and technically, I'm sorry, it's not showing up that great. Technically, it's saying that they're intersecting and they're forming opposite rays. But all you're looking for is making sure that your two segments are forming exactly a perfect X formation. Now, something special happens with those X formations. You get these angles that are opposite. Do you remember what those angles are called? Starts with a V. It's also something you measure when you try to like jump as high as you can. Vertical. Those are vertical angles. So anytime you have an X formation, the vertical angles are the angles that are opposite each other. And they have a special relationship to each other. They're exactly congruent to each other. So if I know that FCB is 155 degrees, I also know that ECD is also going to be 155 degrees. So I can tell because they are vertical angles. If I know that that top angle is 155, I also am going to know that that bottom angle is 155. That is one way. Did anybody else look at another way to figure this one out? Actually, we'll go here because Carson, I've already called on you. Sander?
Alright, so I just subtracted 25 from 180.
Because of that line right there? Yeah. So one thing that you did as you were working through the problem is you were finding this BCD. And it would be a good idea as you find them to write down the angles. I haven't been doing that, I've been erasing, just so we can see the diagram better. But as you write them down, we can kind of see what angles we know and then use that to find other angles. So you said you did what then to find the measure?
Subtracted the 25 from 180.
Yeah. So I know that the full line has to be 180. 25 of those degrees are taken up. So I'm going to do 180 minus 25 to figure that out as well. Either of those are going to work. So we get that X formation. We got vertical angles. So Gabby, your method works. We could also use the straight line. Figure that out as well. Perfect. And lastly, we got ACE. So we know quite a bit about this diagram now. So ACE, we should be able to kind of hone this one in. So let's figure out where ACE is. Here it is. This looks like just a pretty simple angle addition. So the square, we know that means 90. And then this arc and this arc, so whatever the angle of BCD is, that's also going to be the measure of FCE. And we found that out, that's 25, so that means that's 25. So we have a 90 and we have a 25. We're simply just going to use that angle addition, add them up. We're going to get 115 degrees. Did I do that one right? Is that okay with you guys? Yeah. All right, 115 for that last one. So you can see it as you are looking at these diagrams, they're kind of like detectives, and you're unlocking one clue at a time. Okay, I got this angle given to me 65. Now I can start to find another angle. Once I know that angle, that's going to lead me to start figuring out other angles. So you're kind of unlocking things one at a time. This is leading us to kind of logical reasoning and kind of putting our thoughts in order as we start getting the proofs. So we start looking at every time we can prove something, then we can use that to keep proving the next thing. Then we can use that to prove the next thing. And we start to organize our thoughts, these logical reasonings, into making proofs. So eventually that's where this is leading to. So there was 13 through 16 on 1.5. Were there any others from 1.5 that you guys want to take a look at? Anything else? You can ask me individually too if you don't want to ask the whole class. I'll come around to help in a little bit here. Anything else?